Hello, welcome to Chapter 7, Section 6, Adding and Subtracting Polynomials. In this example, we are going to be doing, where we're going to add polynomials. Okay, excuse me. So, in the previous video, we talked about adding monomials, just the parts of the polynomial that are like terms. And we talked about how that can be kind of thought of as geometry. We're going to use that same skill. The only difference is now we're going to add polynomials which are made of a bunch of monomials. So right here, this is a binomial. Bi means 2. It has 1, 2 monomials, 2x squared and negative x. Here I have what's called a trinomial. Tri means 3. It has 1, 2, 3 monomials. When I add these two, this binomial with this polynomial, when I add the two together, I'm still going to add, like I said in the previous video, like terms. Those are terms that have the same variable and they're raised to the same exponent. So if we think geometry, they have the same overall shape. Now here's what I think is really cool about this. I'm going to add like I normally add 3-digit numbers. For example, I'm gonna do this for you real quick, okay? If I do, say, 342 plus, let's say, 512. How would I add those two? Well, you probably learned this way. 342 plus 512. And maybe your elementary school teacher, because this is elementary, maybe your elementary school teacher said, line things up by place value. All right? So the 2 plus 2 would equal 4, the 4 plus 1 would equal 5, and the 3 plus 5 equals 8. But what's really happening here is that I'm adding 300 to 500. So this is actually 3, I'm gonna write it right here. This is actually 3 times 10 to the second power. This is 40 plus 10. So in the first one, that's 4 times 10 to the first power. And then, of course, I got 2 times 10 to what we call the 0 power. Anything to the 0 power equals 1. So this is 342. For the 512, that would be 5 times 10 to the second power, plus 1 times 10 to the first power, plus 2 times 10 to the 0 power. And check this out. What I'm actually doing is I'm adding like terms. The 10 to the second power is not the same as 10 to the first power. The only difference between this and what I'm going to do over here is, here I'm using 10, over here I'm using x. That's cool. So what I'm going to do with this problem is exactly the same as what you did here, except what we call the base. The base here is 10, the base over here is x. The base is just going to change, but everything else is the same. So 2x to the second power, subtract x, that's subtract 1 times x, and then I'm going to put something in here. I'm going to put plus 0. So if my x was 10, it'd be a little complicated because of the negative, all right? But you could think of it as 200, this would be subtract 1 times 10, plus 0. So this is actually a way of writing 190 if x was 10. Since x is going to be something else, it's a different number. It's not 190. By the way, why do we always use 10 here? I think it's because of these. 10 fingers. I think that's how most people learn how to count. For the other one, I have 1x to the second power. I'm going to put it right below the 2x to the second power. I've got 3x, put it right below the negative 1x. And I got the subtract 1, put that right below the 0. I didn't have to write the 0, but I put it in there so you can see how everything lines up. You'll see me do that for all these problems. Now I'm going to add everything up, just like I added things up here. 2 plus 1 is 3, so I get 3x to the second power. Negative 1 plus 3 is positive 2, 2x. And then 0 plus negative 1 is just negative 1. And that's all there is to it. I'm done. None of these can be combined or added or subtracted because they're not the same place value. Place value is just another way of saying they're not like terms. All right, let's move this up a little bit to see this one. Now, I've got some weird stuff here. I got a times b, and over here I got a times b. So these two are going to line up. And then here I got b, and I've got a. These two do not line up. So I'm going to try to write it like this. Negative 2a times b plus 1 times b. I put the 1 in there so we can see what it is. And for the second polynomial, I'm going to put positive 2. I'll put the plus sign because that's positive, 2ab. I don't have a b, so I'm not going to put it here. I have an a. So I'm going to put plus 1 times a over here on the side. Now I said a moment ago I like to show the zeros. So this is 0 times b because there's no b's in the second one. And this is 0 times a because there's no a's there. Now if you just leave it blank like I had it before I wrote the 0b, 0a, that's fine too, because just remember that it is 0. Let's add these up. Negative 2 plus positive 2 is 0. 1 plus 0 is 1, so this is just 1 times b. 0 plus 1 is a. Or sorry, 0 plus 1 is 1, so this is 1 times a. And if you want to write it without the 1s, just write b plus a. Gotta get my desk organized. All right. So let's look and see what we got. We got b to the 5th power, b to the 1st power. Whenever I don't see an exponent, that means it's to the 1st power. So b is the same as b to the 1st power. All right, remember that. It's one of those things that we hide. Actually, that probably needs to be on screen. Here's b to the 5th power, here's b to the 1st power, b to the 5th power, b to the 1st power. Okay, so let's line up all of the things that have the same size. So I got 4b to the 5th power. Just a moment to talk about getting on the side. How many b to the 4th powers do I have? How many b to the 3rd powers or b to the 2nd powers do I have? I don't have any. That means I'm multiplying those by 0. Please remember that they are there. I'm just multiplying them by 0 so you don't see them. All right? This is going to be important in something I'm going to do in Algebra 2 in a couple of weeks. So I just want to say that. So if you end up in Algebra 2, hopefully you'll remember that. 8b, and put right here. 3b to the 5th power, that's going to go below here. 3b to the 5th power. 6b is going to go here. Negative 7b to the 5th power, I want to write it here, but notice that, again, that is the same as that and that. So I'm going to write it down here. I'm lining everything vertically. And the plus b is plus 1 times b. So actually this polynomial here could have been simplified before I added it to that polynomial. 4 plus 3 is 7. 7 take away 7 is 0. So I get 0 of the b to the 5th powers. 8 plus 6 is 14. 14 plus 1 more is 15. That's 15b. And of course, 0b to the 5th power, 0 of anything, just like we've been talking about for these problems, we usually don't see it. So you can just write this as 15b. All right, last problem for this section. I have y to the 2nd power, y to the 1st power, and this is actually y to the 0 power, because remember, y to the 0 power equals 1. So this is 5 times 1, which is 5. I know that that probably makes it a little bit more confusing, so don't panic about it. I'm just trying to set you up for success later. If you remember that you got 2, 1, 0, that helps out a little bit. So I'm going to line everything up. I got 20.2 y to the 2nd power plus 6y plus 5. I'm going to put the 1.7 y to the 2nd power below this. The negative 8 does not go below here, it goes below here, because those are constants, or y to the 1st power, or y to the 0 power, excuse me. How many y to the 1st powers do I have over here? I don't have any. So I can go ahead and put that 0 in there. 20.2 plus 1.7 should be 21.9 y to the 2nd power. 6 plus 0 is 6. And 5 subtract 8 is -3. Now, in the next video, we're going to be doing things that are very similar to that, except we're going to subtract. Every skill will be the same, except for one thing we have to do first, and then it'll look just like this. See you in the next video.